Today we are going to discuss sections of solids. Sometimes the objects are so complicated that it becomes very difficult to visualize the object with the help of its front view and top view. Some objects are hollow. Their internal details are not visible with the help of simple front view and top view. In such cases, the object is cut by some imaginary cutting plane to understand internal details of the object. First, let us know the types of cutting planes. The action of cutting is called sectioning a solid, and the plane of cutting is called section plane. A primary reason for creating a section view is the elimination of hidden lines, so that a drawing can be more easily understood or visualized. First, we are going to discuss section plane. Section planes are generally perpendicular planes. They may be perpendicular to one of the reference planes and either perpendicular, parallel, or inclined to the other plane. They are usually described by their traces. It is important that the projection of a section plane on the plane to which it is perpendicular is a straight line. This line will be parallel, perpendicular, or inclined to the reference line depending upon the section plane being parallel, perpendicular, or inclined respectively to other reference plane. The cutting plane line should be drawn as below. True shape of a section. The projection of a section on a plane parallel to the plane will show the section true shape of the section. When the section plane is parallel to the HP or the ground, the true shape of the section will be seen in sectional top view. When the section plane is parallel to the VP, the true shape will be visible in the sectional front view. When the section plane is inclined, the section has to be projected on an auxiliary plane parallel to the section plane to obtain its true shape. When the section plane is perpendicular to both the reference planes, the sectional side view will show the true shape of the section. First, this is one model problem. A pyramid base, a square pyramid base 40 mm side and axis 60 mm long as its base on the HP, and all edges of the base equally inclined to the vertical plane. It is cut by a section plane perpendicular to the VP, inclined at 45 degrees to the VP, and bisecting the axis. Draw its sectional top view, sectional side view, and true shape of the section. So first of all, step is draw the projections, top, front, and side view of the square pyramid in the required position. So the given solid is square pyramid. The given base side is 40 mm and axis is 60 mm long. So you draw first, which is top view, given as all sides, all base edges are equally inclined, which means 45 degrees to the VP. You will get the first top view, and then you draw the projections from the particular notations. You will get the front view. After that, you draw a section plane which is inclined at 45 degrees to the HP and bisecting the axis as seen in the figure. See, whatever the slant edges from the apex, OA cutting at point 1 and OB at cutting point 2 and O3, OC is cutting at point 3, and finally the slant edge OD cutting at point 4. So you draw the sectional point from the slant edges from 1 dash to 1 and 2 dash to 2 and 3 dash to 3 and finally 4 dash to 4. You will get the point. You draw the horizontal line from 4 dash to 2 1 dash, and from 2 1 dash to 2 1 on the OA edge on front top view, and then you draw arc till touches the OB edge as well as OD edge for getting the points 2 4 on top view. So finally, you get the sectional top view. So for getting the true shape of the section, you draw the reference line which is parallel to the section plane, which is at 45 degrees to the HP. So after that, whatever the distances from the section, what is where you cut, which is from inclined to the horizontal plane, the corresponding distances from the cutting edge point. So the after you adjust the compass to the distances 1 dash to 1, and you draw the perpendicular to the new reference line from 1 dash, and you mark the 1 double dash, and from 2 double dash, that is 2 dash to 2 distance, as well as 3 dash to 3 distance, and 2 dash to 4, that is 4 dash to 4 distance, and you join the points, the 1 dash, 1 double dash, 2 double dash, 3 double dash, and 4 double dash. You will get the true shape of the section. So there is one problem, and you go another model, which is a pentagonal prism, base 28 mm and height 60 mm, 65 mm, resting on its base on the HP, and the axis parallel to the VP, inclined at 60 degrees to the HP. A section plane having horizontal trace perpendicular XY and vertical trace is inclined at 60 degrees to the reference line, passing through the highest corner, cuts the prism. Draw the sectional top view and true shape of the section. So as usual, you draw the pentagonal prism of the given side, which is resting on its base on the HP, like you see. You will get in first stage, you will get the top view as a resting edge, and you will get the front view with the help of the projectors from the top view of the pentagonal prism. Then you draw the which is a plane that is inclined at 60 degrees to the HP. You will get the second stage, that is you tilt the first stage front view with 60 degrees, the axis is inclined at 60 degrees to the HP, and you will get the second stage top view. Then after that, you draw the section plane, which is at 60 degrees to the inclination to the reference line, and in the model the given inclination is with vertical trace is inclined at 60 degrees to the reference line, which is nothing that the section plane is inclined at 60 degrees to the HP, and passing through the highest point on the of the solid, which is a 3 dash. You see at the front view, the 3 dash is the topmost point, right? After getting the section points, you see the vertical edges which are cutting when the section is happened, which are it is first is 1 2. See the cutting points of the particular having 2 points which are cut at one point as 1 dash and 5 dash. The first basic point is the edge is 1 2 is made at point 1, and next point is the solid which is cut at particular point 5. Next is at point 2 and point 3 and point 4. So after getting the points, you join the points 1 2 3 4 5 in the front top view. On the second stage, you will get the sectional top view in the second stage. Next, for getting the true shape of the section, you draw one reference line which is parallel to the section plane. So that after that you join the corresponding points from the cutting edge from 1 dash to 5 dash, which is distance from the reference line. uh, the corresponding section points in the true shape, that is the sectional top view. Finally you join the one double dash, two double dash, three double dash, four double dash, five double dash. You will get the final true shape of the section, right? This is another model. Okay, thank you.